So what's Quickwire been using their 3D printer for? They have one or they have two?
They have two, and they've been making electrical connectors that have been essentially discontinued.
Mm-hmm.
So they're in the old world automotive space, and there's still a kind of a subset of people that are restoring old cars,
Yep.
and they like to keep things original, and they've got connectors like headlight connectors and things like that they're printing now because they've lost access to supply.
Yeah, and obviously they buy a lot of connectors from a variety of vendors, but those specific connectors must not be high enough volume through their standard catalogs, but the cars still need to be made. Or
Yeah,
the harnesses for the cars.
Yeah, it falls under like the low to medium volume,
Yeah.
number, which isn't enough to keep the injectors going, but
So
they still need them.
They're making the plastic components only, or are they combining?
Correct.
Okay.
Yep.
So where do they source the other, like the copper and the terminals?
So
and
the
that type of
terminal
stuff.
The terminal is a more universal terminal.
I see.
It's used across many different connectors. So it's the terminals aren't the issue, and just by using the machine, it gives them the flexibility to literally use any terminal as long as it meets the spade specs.
Yep. Yeah, and I think it's interesting because when a lot of people think about plastic 3D printers, they think about the use cases being like knickknacks and trinkets and
Toys.
toys and charms on necklaces. And I would say, like, when I first started paying attention to 3D printing, there was it Makerspace? There was some website where you could download the CAD models, and most of the CAD models that were being designed were kids' toys. And
Thingiverse.
Okay.
Probably the most popular one.
Yep. And then you and I were at a small 3D printing conference a couple years back in Texas, and a lot of geeks there, like straight up geeks, coders and software engineers, and people that were trying to find applications to use their programming skills and their computing background. But it seemed like they were more disconnected from traditional, like, CNC type manufacturing. And this technology and this concept, it's additive manufacturing, so it's building up layers. But when it comes to computerized digital manufacturing, there's a lot of other processes that we've been used to in a lot of machine shops in this area, and people that aren't necessarily considered tech people that have been programming and using digital manufacturing for a long time.
Yeah, no doubt. I mean, the CNC.
It's using CNC.
It's essentially the same
technology.
code.
Yeah, same code.
Yeah,
okay.
it's XYZ, and then along with other commands to, define things like temperatures and flow rates and things like that, layer heights. But it's the same principles as CNC machines taking billet or blocks and machining it down to certain dimensions.
In that case, getting rid of material. In this case, adding material.
Yep. So there's no waste. There's interesting benefits to both.
Yep.
There's things you can do in that world that can't be done here, and obviously things that can be done here that can't be done in that world. Mostly, a lot of it is material availability. There's a lot of time, effort, and energy and resources being put into material development in the 3D print world. It's come a long way in the last few years since I started getting into it, and but it's it's still not close to the CNC world of aluminum.
So how do you classify the different materials? And the printers that we have here at Wisconsin Lighting Lab uses a plastic that comes on a roll. It gets heated up and the layers get applied. Yeah. What are the different material categories?
I mean, pretty much everything. A lot of the material categories you'd put in more of like a hobbyist type of category.
Yep.
But there are some more professional or higher grade materials that come onto the scene, and that's kind of the space that we live in. And I think a lot of times it's not thought of as there's a small difference between PLA, which is considered like the most common and simple material, and then there's this whole material technology world where we've got chemists more or less creating brews and batches to allow the plastic to get to different ratings when it comes to temperatures or rigidity or flammability, that type of thing.
Yep.
So those types of materials are becoming more available, and they're being recognized, through certification companies and things like that are starting to make a lot of these materials more relevant in the commercial space.
Yep. Yeah, and that I think to a lot of the tinkerers, that is one thing that maybe isn't part of the consideration when making things. If you're making a charm and a necklace, you're not really considering the flame rating or having to run it through UL. And there's been a 1,000 different kind of milestones and checkpoints that we've had to go through the last 2 years. How long have we been?
Yeah, I think we've had them 2 years.
Yeah, and it was it's been a great process because we can make. I think we've done the calculation 50 or 60,000 parts a year. So if we have our printers going constantly, it's tens of thousands of parts. But certainly there were a lot of challenges along the way. So as far as CNC, what is your background with CNC? How much of the skills that you've developed related to 3D printing, if you kind of looked at what was required to get to that point? Was it more of the the programming side of it? Was it the hands-on side of it? Was the CNC side of it? What do you if you kind of had to weight those different things? What does it look like for you?
CNC world, I have little experience.
You did take shop class in high school.
Shop class in high school is about the extent of it. Programming in the physical machine world, little experience. Most of my programming knowledge has been on web and more computer software type of things. No experience in the material world. It's been mostly just like it's come out of interest of just kind of building things and seeing the process kind of fascinating. And there's been like a weird little interesting drive to get creative with the simple machine to make it useful in an industrial type of atmosphere.
And we've taken more of the print farm approach, where we have print cells as opposed to giant expensive printers. We have a whole room with 11, 12 printers, and that has allowed us to get in the game. A lot of 3D printers, the more industrial grade ones are hundreds of thousands of dollars, and we pretty much spent it was like $10,000 to $12,000 to get a bunch of them.
Yeah, in the ballpark.
And obviously a lot of time to get them set up. But did you started tinkering this with this type of printing at home a few years ago, or what did that look like? Was it a lot of YouTube videos, or just kind of following your curiosity?
The 3D printing world's just kind of been interesting, and I started to realize it didn't cost that much to get into it, which is still where 3D printing mostly lives. It's like a hobby world, which is one of kind of the digs against it, is that it's not going to get out of the hobby space. But I don't think that's quite true. I think it's just more of you got to get more creative and flexible with the use cases.
And it's not going to solve everything.
No.
There's a nuanced approach to this digital manufacturing. In some cases, you might need milling. Some cases, you might need injection molding. Some cases, 3D printing works.
Yep.
But that was when we were down in Texas too at that conference. You can tell there was this hope that 3D printing was just going to completely take over all other types of manufacturing, and obviously that's not the case.
Yeah, the big pitch is distributed manufacturing. So
it's like
instead of
decentralized.
Yep. So instead of shipping parts and to everybody's home, you just ship them a file and they make it. And I think there's some weight to that. But like you said, it doesn't solve everything.
Yeah.
By any means. The most interesting thing here has been the speed of kind of turning ideas into a real thing. I was just telling you a story yesterday. We print this enclosure for a circuit board that we use, and there aren't any like requirements for the casing. It doesn't need to go outside. It's pretty much just like a handling protective cover, and the provisions we had for mounting the case didn't quite. It wasn't quite set up ideally for the application. So I think it was a 10-minute discussion around how to make it better. One of our engineers went back to the drawing board. He had a new design, was printing a prototype within 20 minutes. That took a couple hours to print. Everything looked good after that couple hours. Another 10 minutes later, we had a file on the printer, and we had 7 machines printing that case in production. So a 3-hour turnaround was a design, adjustment, discussion, prototype, and product in production, which it'd be impossible to do that with an outside vendor. Or
you have to buy a generic enclosure on the internet that isn't designed for our custom circuit board, or you have to tool up for an injection molded part, which is really how we got started. Is we had some lighting parts and accessories. We were doing some onshoring. We used to buy these from China, and we started to work with more vendors here in Wisconsin to source a lot of our mechanical parts, and we went to tool up for an injection molded part, and it was $12,000 for one part. And we have a tendency to change designs as we learn more information. So it's like, man, we're gonna have to spend $12,000 for a piece of plastic that there's no way we're gonna get it right the first time. Oh yeah, and by the way, to do that fixture, we need 5 different parts. So $50,000-$60,000 to get in the game and hope that you did it right the first time. Not to mention that it takes 5 months to get the tool created, and then there's lead times and everything else. So for us, it was really, because we were on a budget, we said, are there alternatives? And, we did the math, and, this worked out, really, really well. And we're a low to medium volume manufacturer, high variability. So it works really well for us. But I think what you're describing is that it gets rid of pain points. There's so many jobs that are always this close to being right, but there's these little things that can make our lives easy, and that's where these printers seem to shine. Again, not to mention the quick prototyping.
Yeah, I don't know how many it'd be interesting if we kept a tally of how many individual variations of stuff we've printed on these things. I mean, it's in the hundreds.
Yeah,
I would guarantee it.
Yeah, and I think what's interesting is a lot of the products that people use go through some type of automated manufacturing process. Now, I've heard statistics. It's like 70% of products and parts use some type of automation. And this type of automation technology has been available to large companies for a long time. But I think what's cool is, in the same way that personal computing went from only IBM and huge companies having access to it, now that technology is becoming more distributed to small and medium sized manufacturers. So what other types of I guess desktop CNC technology do you see people using around here? I think it's Sam for instance.
Yeah, I think you can do quite a bit with some pretty flexible things. CNC tables, lasers, things like that. There's some kind of maker level products that are pretty powerful and could probably do a decent job of handling some low volume stuff, definitely prototyping. There's I consider a lot of like wire processing equipment, kind of desktop type of stuff. I think that type of thing also really creates a lot of flexibility. I don't think wire processing equipment is typically thought of as in the same realm, but it very much is.
Yeah.
And that's been around for, a lot of that equipment's been around for decades and decades. to take a wire processing machine and compare it to the parts on something like this, that it's using a lot of the same parts, a lot of the stepper motors and small circuit boards and control boards and things like that.
And that stuff's is it typically programmed, or I mean, I guess depends on the level of the level of machinery.
Yeah, you're not dealing with 3D files. You're
Yeah.
just defining. You are programming it, but you're just defining lengths and wire gauges and things like that. Again, same but different.
Yeah. What do you think? What do you think stopping more people from seeing the use cases? Is it kind of the disconnect between the programmer, tinkerer folks and people that are used to working with mechanical parts, or what do you see there?
I think it's probably twofold. I think it comes off as daunting, and I think the initial kind of learning curve is relatively slow, but there's so much information to help significantly close that time in which the learning curve's there. I help Quickwire kind of onboard their stuff, and I mean it would have extended the timeline in which they could have onboarded that stuff a long time. Probably a few months of just trial and error, which is kind of what we went through. But then the other portion is just kind of the engineering kind of skill set. Yep. So understanding and quick turn of creating 3D models and designing it in a way that is designed for 3D printing, and then probably just creativity beyond that.
Mm-hmm. And probably the culture of making mistakes and continue just like iterating constantly, where I think in a lot of engineering teams it's give me the hard requirement and let me execute on the requirement, where we try and keep a pretty tight feedback loop and just continue to improve at a rapid rate.
And I mean just the mentality of a lot of small and medium-sized businesses isn't necessarily, I don't know, I don't even think a lot of small to medium-sized businesses have like 3D modeling skill sets in-house. A lot of times that's just kind of outsourced because they just don't need it full time. Which
is interesting because a lot of the small and medium businesses their value is the low run customization. It's you think about like a job machine shop around here, Mercury Marine, they don't use the huge fabricators to do small run stuff. They use the smaller shops where there's a lot of information in the owners or the machinist heads, and it's I think those types of operations are really the ones that probably you need to embrace this more, because it can supplement a lot of the value that they're creating for their customers. Yeah,
that or they've just found a niche.
Yeah.
They just settle into a niche that's, enough to support a small to medium business, and just kind of run with it.
Yeah. Yeah, the business keeps flowing. So do you think it's representative of any trends that you've seen in the past? I know we've been involved with music and web design, and I see where back in the 90s when we were I guess it wasn't the 90s, early 2000s, recording in a studio that was a couple $100,000 in equipment to to record a song. Now you have a MacBook computer and it's a $2,000 computer. It comes with software. Look at web design and what it used to take to build an e-commerce site or a website. I mean, it was extremely, extremely difficult. And now I see those same trends happening in in manufacturing. So I guess where do you see that going?
Yeah, I think the web design thing is a good example. I think just this table setup, the podcasting setup, that world is a good example. It starts off as super hard, super technical. You could make an argument that the Bitcoin world is in a similar type of process where it's incredibly complicated. It sounds impossible to get into, but then over time there's like tools that just break down the barrier to entry to make very complicated and productive things more simple each day. And I mean, it, there's a lot of that I guess is in our brains right now in terms of the direction and the place that we're thinking when it comes to making products, designing products, and engineering them. And I think this is just, like you said, it's like one example. There's a lot of this technology is just more accessible, and it's skill sets that are flexible and able to attack a lot of this stuff. Computer vision things, I see a lot of that kind of coming into the mix. Just communication in general.
Yeah, I think of the story. My grandpa was hesitant to get a fax machine, like it was this crazy technology thing that it was going to be. What's wrong with mailing a quote to a customer?
Yeah.
It's like, what do you mean we need a fax machine? And I think that again, because it's in a tool that empowers small and medium businesses because it allows for customization and getting rid of pain points for customers, but you have to be able to know how to use it, and getting into a price range that is more it's more palatable for more people, I think is key. And also I think like the drag and drop tools, I look at like Squarespace, like build a website. It's if you build a website with 1 million SKUs like we have, you're not gonna be able to use Squarespace for that.
Not now.
But it's if you have a website that has a couple products on it, you can build a website relatively quickly. So I think it's the automation and it's really an interface problem. It's computers used to have to they used like punch cards and things to program a computer and a machine, and then there was a green screen, and then it's really the UI becoming easier where the machinist on the floor or the person running the casting or the injection molding equipment, they have an interface that allows them to not be a computer programmer but use all the knowledge they've accumulated over 20, 30 years to empower them. So I think it's the interface. Anybody can use a phone, anybody can use an iPhone at this point. How do you have the interface that easy for this type of manufacturing? Be interesting to see when that happens.
Yeah, it will. I think I think the website thing is a great example. When we built the first e-commerce site, it was 9 months of just painstaking development and trying to learn how to do something as simple as take payment online. And I could stand an e-commerce site up in 35 minutes right now. Ready to take credit cards, pictures, product options, all that stuff. If you really wanted to, and to your point, that type of stuff or that mentality exists in the manufacturing world, and more is entering that world every single day. And it's turning into kind of a sea that you got to navigate and try to understand and figure out what is attainable. I guess.
And I think there's like cultural divides between people with these skill sets.
Yeah, if you talk like 3D printing in the industrial and manufacturing space, immediately it's $350,000 machine. And it's perfect finished quality and all that stuff. It's like, well, is that actually what's needed?
Yeah, or it's like, have you been told 1 million times that is what's needed, and it's not attainable. And that's
where the creativity comes in, I think.
Yeah, and just the culture of experimentation and stuff like that. So, well, what else is interesting on topic?
Well, I think the same type of thing is pushing through into the technology of the lighting space. We talk a lot about it's kind of related, but it's more on the control side of things. But the interface in which the products are interacted with on the customer side of things it's the same progression.
Mm-hmm.
It's the exact same thing. For products to interact with and be aware of the space is nothing new, but the ease in which it happens and the ease in which it is, which you can interact with them, is where that same progression is happening on the product side as it is on the machines making the products. So it's literally just happening everywhere.
Yeah. Yeah, and I think it's so easy for people to get overwhelmed with technology because I think there's a lot of companies and a lot of products that have not done a good job of making it easy. You know, you look at, like certain vehicles that just try and pack as many sensors and as many screens and as many electronics into the cars, and it's just people get frustrated. So yeah, that's the approach we've taken on the controls team, which you also run, is just make it as easy as possible. Can your grandpa, can your grandma run this lighting system? If the answer is no, well, it's like, well, there's more work to be done yet, because they can run an iPad. If they can run an iPad, they should be able to control lights. And I guess there's probably certain, once you get into the physical world, you're dealing with dangerous things. You're dealing with temperature. You're dealing with fumes. You're dealing with noise. I mean, anybody that's walked inside of a manufacturing facility, it's a little bit different than just a screen. So there's other controls and precautions that need to be taken with manufacturing, but it's all stuff that'll get ironed out over time. Well, cool. Well, unless anything else you want to run through, should be good.
No, I don't think so.
All right. Thank you.